All right, so triangle similarity. So first off, let's remember some of our rules that we have. So we have angle similarity. We have side similarity, and SAS, side angle side similarity. All right, and this has nothing to do with the congruence that we learned before. So if two triangles are similar, the corresponding angles are congruent. We can write the word congruent or just use a symbol. And their corresponding sides are proportional, which is why it's really important to be able to set up those fractions and do the math. If two triangles are congruent, then the corresponding angles are congruent and their sides are congruent. So that's the difference between congruent and similar, right? Notice the angles are congruent either way. What's different is the sides. If they're similar, the sides are proportional. If they're congruent, the sides are congruent. And the scale factor, if they're congruent, is 1 to 1. Why? Because they're the same. It's the same number. All right? So, can these two triangles be proved similar? Now remember, there are times when you're going to have to maybe flip a triangle around and try more than one. But right now, the way they're oriented, we're going to look at this like those two, and those two. So I'm going to do 24 over 8, 33 over 11, and 21 over 7. And hopefully they're all equal. Now, remember, there's 3 ways to do this. I could cross multiply those two, and the first and the third, and do all that math. I could also reduce these fractions, and if I reduce these fractions, I would get 3 over 1, 3 over 1, and 3 over 1. Or I could just simply divide, and I would get 3, 3, 3. So in other words, the smaller triangle is 1/3 of the big triangle, and the big triangle is 3 times the smaller triangle. So are they similar? Yes. And if we follow this, BDC, it's going to be TVU. And remember, you've got to go in the same order. And why? Side similarity. And the scale factor is 1 to 3. Now, why is it 1 to 3, not 3 to 1? Because we're saying we're going from the big one to the small one. Okay? So remember, this is very important. Think about which way you're going. If you're going from the big to the small, then the scale factor is 1 to 3. But if we switch these and said TVU to BDC, then we would have switched these and done 3 to 1. Now again, am I going to be that picky on the test? Probably not. I'll just point out that it should have been the other way, because at least the important thing is having the main numbers. But just try to think about, am I getting bigger? Am I getting smaller? All right. Now the key thing to remember here is, on the second one, notice we have R and M marked similar. But we can also mark these two. Why? Vertical angles. We want to always mark vertical angles. So we don't have any numbers. It doesn't matter. We have what we need. It is yes by AA similarity. Now we got to be careful in this one. RSL. So we're going from R that has the 1 arc mark, then to S that has no arc mark, and then to L, which has 2. So we're going 1, nothing, 2, which means we need to go 1, nothing, 2 there, and do M, N, L. Now, this is one where if you do the wrong order, you will be marked wrong. You've got to look at the little hints, all right? And on this one, you look at the number of arc marks. 1, 0, 2, you want to go 1, 0, 2 on the other triangle. All right, number 6. First off, you want to fill in numbers wherever you can. So in this case, we have the total number here of 156. We also know this is 36. So if we do a simple subtraction of 156 minus 36, that gives us 120, which tells us this piece is 120. All right? And therefore, at this point, we can set up our fractions. Now, remember, there's two triangles here. There's the big triangle and the small triangle. All right? So, the big triangle, if we add these together, that gives us 143. And the small triangle, we already know is 156. Okay? And the small triangle is clearly 110 and 120. So if we set up our fraction, 110 over 143 equal to 120 over 156. And if we cross multiply those, we'll get the same number. If we reduce them, we'll get 10 over 13 and 10 over 13. And if we just divided them, we would get the exact same decimal. Right? So that means we have yes. How do we have it? We have side, angle, side. Well, where's the angle? It's this one. This angle is the same on both triangles. So we have side, angle, side, and side, angle, side as we go around the triangle. And then SRC, we're going this way, SRC, so we want to say ABC. Now, remember, SRC is the small, this is the big. So with our two numbers, 10 and 13, since we're getting bigger, we want to say 13 first and 10 second. We want to write an improper fraction, 13 over 10, not 10 over 13. Even though we had 10 over 13 here, we're getting bigger, so we need to make sure we write it as an improper fraction. All right, number 7. All right, here we have 1 and 1, 2 and 2. Right off the bat, we know we have AA similarity. We don't have any numbers. We don't need any numbers. We have angle similarity. But again, we have to pay attention. SRQ. So we're going from 1 to none to 2. So we have to go from 1, G, to none, F, to 2, E. G, F, E. All right, page 2. Always, always, always mark vertical angles, always. So what we're hoping for in this one is SAS. Doesn't mean the numbers will work out, but we're hoping for SAS. Okay? So we check our numbers. Now, we may not always do it right the first time. Okay? But what I'm going to do is I'm going to look at 16 is smaller than 24. 104 is smaller than 156. So I'm going to try 16 over 104. There's that little trick there. And 24 over 156. Now, again, I just take my calculator and I multiply. 16 times 156, I get 2496. 104 times 24, I get 2496. So it's checked. They are equal. So it is yes, and it's going to be SAS. But because I need the scale factor, I still really should reduce this. Okay? And 104 divided by 16 is 6.5. Okay? So it doesn't go evenly. So we just want to reduce the fractions. So we want to divide by the biggest number possible, and this ends up being 2 over 13 when you reduce it, or 13 over 2, depending on how you wrote the numbers. Now remember, on this one, we're going from KLR, the small, to the big. All right? So KLR, we got to look at these letters here, and we're going to say TSP to go in the same order. And since we're getting bigger, instead of writing 2 over 13, we're going to write 13 to 2. Because we're trying to get bigger. So we write the bigger number first. Basically, the big triangle is 6.5 times the size of the small triangle. Okay, number 9. We have 3 numbers. So obviously what we're shooting for is SSS. All right? Now, if we look here, 25 and 25 are the same. Well, and 30 are the same. Well, 15 and 15 are the same. So they're actually, these two triangles are actually congruent. But we're testing similarity. Well, congruent angles are similar. They're just so similar, they're actually equal. So it is yes. It's SSS similarity. And with STI, we're going to go LKU. We're going to go in the same order. And the ratio is just 1 to 1. They're congruent and similar. So it's a special little triangle. All right, number 10. This was kind of a tricky one. All the information we need is there, but it's kind of hidden. So this angle is obviously congruent to itself on the big and small triangle if we separated them out. All right? So we have one angle. Since we have parallel lines, we have corresponding angles here, and we actually have corresponding angles here. So we actually have more than we need. We have AA similarity. And MUI, so it's yes, MUI goes this way, so we're just going to go the same way, MST. So we had more information than we needed. Now, if you remember from last section, notice how this is half of this number, 15 and 30. So it's a 2 to 1 ratio on this one. This is a mid segment. Now, it's not drawn very well because technically this is 13 and that's 14. It's not drawn well. It should be more like right here. It's just badly drawn because this is a mid segment if these two have a 2 to 1 ratio. So sorry for the poor drawing, but the answer is yes. And again, since we have this angle here is equal to itself, we have SAS similarity. Side angle side. So we have 13 and 14 equal to, proportional. All right. And then KLM, if we wrap it around the same direction, it's going to be JLO, and it's a 2 to 1 ratio. Because KLM is the small, and this is the big. 1. Okay, number 12. Have to do a little legwork here. Okay, 60 plus 80 is 140. That leaves 40 degrees here. 80 plus 40 is 120, and that leaves 60 degrees here. Now, even though these triangles look like they're, oriented the same way, and this goes with this, and this goes with this, that is not true. Okay, it's not true at all. The 40 goes with the 40. The 80 goes with the 80, and the 60 goes with the 60. So you got to be careful when you write this. So the answer is yes. We have more than we need. We have 3 angles. We only need 2, but you've got to be careful. N, which is 60, goes with R. S, which is 40, goes with D. And then 80 and 80, A. Okay, most common wrong answer there would be to go NSU and go DRA, and that would be wrong. Last but not least, always, always, always mark those. Okay. Again, we look at this, and it looks like, we could try 14 over 72 and 12 over 84 to save time. I'm going to tell you it's the tricky one where it's wrapped around. So we want to do 12 over 72 and 14 over 84. If you tried 14 over 72, it would not have matched up, which is fine. You try, you're wrong, you switch it over, and we get 1 over 6 and 1 over 6. So it's yes, SAS, similarity. Now you got to be careful. EFN, since it's backwards, it's going to be LMN because it's twisted. And again, EFN is a small. We're getting bigger. So instead of writing 1 to 6, we write 6 to 1 because it's getting bigger. Always pay attention to that.